Good morning, everyone, or afternoon, depending on where you're located at. We're at our training facility in Huntsville, Alabama. My name's John, and welcome. Today, we're going to cover the kitchen microwave. This is SKS MD 2401S. So we'll be covering that. We'll be going over some of the operation, touch on installation, get into teardown, and also into troubleshooting. All right. So this is the SKS MD 2401S microwave. Now we have a partnership with Sharp. You might have noticed this if you guys work on a lot of microwaves. This might look familiar to you. Kind of like the design. It's unique. It's a drawer. It was designed to go in the lower cabinets. And one of the things that it could benefit is people with ADA compliance. Let me cancel that. I'm touching buttons. I should have. And this is good for people in wheelchairs or shorter people. Kids can get into this microwave, if they're a little bit shorter. Over the range microwaves are great, but the problem is if you're, like I said, confined to a wheelchair or you're a very short person, it's difficult to get up there. So this will be the perfect design for it. Okay, so a couple things about operation. Control panel is very, very simple. I unplugged it and I'm going to show you how to set the clock first. It's kind of a two-step process. There isn't a button here to set the clock. So what you have to do is we have one button here. It says timer settings. You hit it once, you hit it twice, and it tells you, what to do. So the first one that comes up is set time. So what do we got? 11:05. 1105, and then just hit the start button, and now your time is locked. Now there's other features in here. There's timer. You can also activate the timer. You can also turn the audible beeps on and off. There's one called auto start. I didn't quite get what that one was. I keep on getting an error when I try to use it. We have an engineering sample right here. I don't know if things have changed on the actual production one. So I'm kind of guessing, and if any of you guys know, let me know if I'm wrong, but I think the auto start means, this is the best thing I can come up with, is if your, this feature over here, stop clear button, that was designed to kind of protect the switches, and all manufacturers kind of feel that same way. They include that in there. And what's happening is you're in the middle of the cycle. Maybe you got a couple minutes left and you notice that the food is starting to boil over or you want to stir it. Most customers, and I'm guilty of it too, will immediately go ahead and open the door. That's pretty rough on those door switches. It could cause them to fail prematurely. So that's why they put that stop feature. So I'm thinking the auto start might be is if you do hit that feature to just stop the microwave when you close the door, what I'm thinking is, and tell me if I'm wrong, it might restart it, what having to, instead of going to the start feature. But like I said, I try to play with it, but I keep on getting an error code, so I don't even know if it was programmed on. And there's a couple other settings in there that you can go into that. Now, common settings, of course, microwave popcorn. When I first started working on microwave years and years and decades ago, one of the problems was they didn't want you to use microwave to cook popcorn because of the low moisture content. You got to remember when I started working on microwaves, they were glass tubes. They were very gigantic magnetrons and very expensive. And one of the ways they used to tell you to cook popcorn in there was put it in a paper bag and put a pat of butter in there and then roll it up and then it'll pop and automatically butter it. But you see where I'm getting, it was kind of a dangerous thing to do because of the grease. The paper bag absorbs the grease from the butter, and if you let it sit in there long, it started on fire. So in the earlier days, we used to discourage it as much as possible. Now they kind of embrace it. They have settings just for popcorn. We got reheat, we have cook. I like this power level button. It's really nice. Once you set in the time, you can just scroll down. Now, power levels are microwave, and most of the manufacturers I worked on, when they had the different power levels, what they would do is they would vary the time that you apply power to the primary side of the transformer. So if you were selecting power level 10, which is 100%, basically they would always apply power to that magnetron, not magnetron, but to the transformer. use 90%. They just vary the time that we're sending voltage to that primary transformer. Um, we at LG and other manufacturers I worked for used a 22-second frame. So if you were at power level 10, they would keep the microwave powered up 100% of the time. So in that 22-second, basically what they would do is it would never turn off. Now, if you went to the 90%, it would be off for 4 seconds and on for 18 seconds. And as you went into the different power levels, one side would go down while the other side would go up. Okay. Now, Sharp is using a 32-second one. I don't know what the reasoning behind that. I guess it really doesn't matter. You can use 32 or 22. Maybe they feel it cooks a little bit better. This is a 900-watt microwave. Okay, so maybe that's part of the reason. Don't have much communication with Sharp, so hard to tell why they really went that way. But one of the features on here, and you can see this button over here, this is a open and close button. So if you hit this, it'll slide out the drawer for you. And then you can either push it in if you want to. Once it activates that, it'll bring it back, or you can use that button to close it. And then the other one is a more menu that gets into more precise sensor cooking. And then we have a defrost feature on there. So they made it very, very simple for the consumer. Okay. Any questions on any of these operations? If you do, just type it in and I'll answer it for you. So. All right, I'm going to talk about installation. It does come with a installer's guide. Kind of read through it. Really doesn't look like anything tricky. One of the things, remember, these are going to be under the countertop. So one of the things you have to do is, you know, there might be some space from where the microwave slides into the cabinet to the actual top of the countertop, so that you got that little gap in between there. And this can create a problem if, you know, the door is open and there's something heavy inside there. We can actually tip this. So what you have to do is you have to, and we don't give that with you. The installer will have to create one. All it is a 6-inch piece of block of wood, and it's secured to the back of the cabinet, and it rests in the back corner here. And so that's your anti-tip device. So they say whenever you're moving it to another location, make sure that goes with it. Now, the other thing under if it's flush mounted, they give you this, and this actually came like this. It was on this piece of wood here. Just peel this off. Got a notice on here, don't throw this away because you might need this. And this is, they call this an air deflector. And the way it was designed is you got your opening, you followed your opening for this to go in, and you probably got a board on the bottom where the microwave itself is going to sit on. So this would mount this way. So you attach the screws, and then your microwave is right above it. And they call it an air deflector. I think, I'm just trying to figure out why they would need this. I think it might be a situation where, you know, you've got that blower blowing through there. Maybe some steam might escape through the bottom and get through the cabinet. I don't really know the reasoning behind it, but it says that there are cases where you'll have to install that. So if you guys know the reasoning behind that, just let me know. I couldn't find any more information in the owner's manual of how important it was to make sure that is installed in there and what could happen if it isn't. Now, the other thing that you'll have to install is, I'm going to open this door real quick, is we have these little brackets. There's 2 of them. They don't come installed. You'll have to go ahead and screw them on. There's a little package with the screws in there. There's 3 for each side. And then there's 2 screws on either side that you secure it to the cabinet. Okay. So, I'll show you a couple ways I've practiced servicing this. There are certain cases you're going to have to completely slide it out to service it. Other times I can pull it out maybe about 6 inches, and I can service things like the lamp or the door switches. Other things like the high voltage section, some of the boards in the back, you are actually going to have to go ahead and pull this out. This is nice though, because it's low to the ground. Kind of your center of gravity is right here. It's not like you're dealing with something up here trying to get it down and wrestle with it. This is nice because I can have something underneath here to support that while I'm pulling it out. So, all right. I think I got everything covered on installation. And like I said, got any questions, just refer to this book here. It's pretty concise. All right. All right, let me see if there's anything that we missed. Anything in the chat box. Looks good. All right, let's show you how to take this apart. Now, we have three boards that we're dealing with. We have a board up here, and this is actually what Sharp calls the control board. And it's your Micon up there. It also connects to the user interface and to the display board. So I'm going to show you how to take that off. We also have two boards in the back, and one of them is the power board. I kind of look at it as a relay board. There's 4 relays on there, and they're marked as RY 1, 2, 3, and 4. Now your R1 is going to the lamp assembly. The R2 is actually the one that breaks the not the secondary, but the primary side of your high voltage transformer. That's how we get the different power levels. And then we have the R3, I believe that one's for turntable, and then R4, I might have them backwards, but the other one is for your blower, your cooling fan for your magnetron. Now there's also another little board down there, and they call that a switch power supply. Basically what they're doing is they're taking line voltage and they're converting it to 24 volts DC. And they use that voltage for a couple things. We've got relays that activate they claim it's about 26 volts. When I was checking it, I got somewhere between 24 and 26 volts. And I can't think of the other thing offhand. Oh yeah, the little motor for the door runs off 24 volts DC. So those are there too. Now we have door switches here. Okay, so you're typically familiar with 3 switches that any manufacturer uses: the interlock switch, the secondary switch, and the monitor switch. Let me explain these switches here and what they're doing for you. Now, one of the things about servicing those switches when you're doing tear down is if you pull this out of the cabinet, maybe a good 4 or 5 inches, each one of these has this little access panel. You can unscrew that, and then we can actually check those switches, see if we got, burned contacts or burnt wires, or do a continuity check on those, make sure the switches are okay. But there's going to be 2 of these switches on both sides. Okay, and I'm going to remove this cover, and you can actually see where these switches are located at. All right, so on this side, and this is the right side, the top one is actually your secondary switch, and the bottom one is your monitor switch. Now on the other side, there's another configuration of switches that looks just like this, but the top one is going to be what they call the third switch, and the bottom one is going to be called the stop switch. So let me explain to you what each one does. Of course, you know what the monitor switch is. This is a normally open, normally closed switch, and when the door is closed, that switch is open. These are going to be normally open. These will close when the door closes. So secondary switch is just the safety on there, designed to not to have the microwave come on whenever the door isn't closed. Now on the other side, there's a third switch, and that's also another monitoring switch. Remember, the design here is not what you're familiar with, that you have a door swing that closes this way, so all those switches can be mounted in one configuration. But I have a drawer here, so I have to make sure that something doesn't happen to the tracking, where when these close, this switch closes, but maybe something is keeping this from going all the way back in. Now I have a spot here where I can get excessive radiation leakage, and so that 2 switches monitor that to make sure that we're running under a safe condition. So both of those switches have to be closed when the door is closed. Of course, your monitor switch is going to be open. Now the 4th switch over here, we call that the stop switch, and all it's doing is monitoring the track movement of this door. Basically, it's a 5 volt DC signal, and it's looking for 5 or 0 depending on the status of the switch, what position it's in. So that's how it knows when it's back to the closed position. Now, one of the things I didn't mention is the interlock switch. Okay, technically they don't have an interlock switch. They have a primary interlock relay. So that's that RY2 relay on that power board. So technically that's not a switch, it's a relay. So the other safety devices on here is we have a cavity fuses, which is located here. And we also have another fuse on your magnetron. That's in case the magnetron gets too hot, maybe the blower is not working. And then of course we have a choke system in the door like all manufacturers. There's a dense material on the inside that absorbs microwaves. And of course you have your screen here, which the holes allow you to view what's cooking inside here, but the holes are small enough where the microwaves can't actually leave that cavity right there. All right, so let's show you, I'll start out with the control panel, how this comes down. It's really simple. I left one of the screws out because just trying to save a little bit of time. I'm gonna kill power here real quickly. And got 4 screws in the back. Maybe I can turn this around so you can get a better picture of what I'm doing. Probably going to run out of space and have a lot of pivot room. But there's supposed to be 4 screws here. I left these 2 screws out and just put these 2 screws back in here. So let me go ahead and remove it. Now I didn't have it. There's a little tab that holds it in place down at the bottom. Be careful of this thing because I was doing this the other day and I wasn't holding onto this, and thing just fell down. I didn't have it snapped in, so the control panel came down. So let me open this door and I can release that. So let me pull this off. Okay. So these are those little tabs I was talking about on the bottom. So you have to have the door slightly ajar to get to it. So this is that control board I was telling you about. Very tiny little board right over here. And I've got this little connector that's going to plug into there. It's kind of foolproof. Don't forget, we also have 2 other things. You got your user interface and you got your display board. So everything is up in here. I'm going to put this off to the side. Now, one of the things, and I don't think this is something maybe the consumer can do, that's changing the light bulb. First of all, they would have to pull it out, and they're going to have to pull it out about this far. All right. So the first time you do this, to get this little cover off, I'm going to tilt this a little bit so you guys can see what I'm talking about. Let me move these screws. Okay. Make sure I don't tip all the way over. You know what? Let's just lay this like this and we can do it that way. All right, so they give you this little access panel here. This has obviously been taken apart before, but what you have to do is see these little tabs here. You have to snap them off. A pair of diagonal pliers. There's like 1, 2, I think there's about 4 of them. And I added the screw because I'm reusing this. So basically what you do is just screw this off. Now this has got little tabs that it kind of fits into. Now be really, really super careful right here. This is sharp. Looks like they deliberately went ahead and sharpened it for me. And you're going to reuse this again. You just flip it over the other way. And basically it fits into these tabs and you'll have to supply a screw to screw that in. So there's your lamp assembly down over here. It's got 1 screw. Be really careful when you're taking that out of there. I did this morning. I got the screw out with no problem, but the problem is getting it back in again. I put it on the actual part of the bulb there, and when I was trying to get it back down into the little opening, the screw fell down. So I was able to retrieve it, but it's really easy to use. Kind of wish I had a magnetic screwdriver. I'll pull this out to show you guys the bulb. The wires are tight there, so it's a good idea to take these connections off. And like I said, I got to be real careful. I should be wearing gloves. These are super sharp. So I guess it's a sharp microwave, so that makes sense, right? All right, so I'm going to go ahead and remove this screw, see if I can hang on to it so I don't lose it. I got the screw here. What am I hanging up on? Oh, I see. my wire connectors in front of that. So this is what screws it to the actual cavity of the microwave, and kind of looks like a specialty bulb. I don't have to go ahead and look for it, see what the part number is. This is a 30-watt bulb, so I think it's one of those specialty bulbs. Maybe you'll have to order through Sharp or check Amazon. Amazon's got everything. Maybe they got a bulb for this. But customer will have to decide if this is something they feel they can do themselves, or they might call for service to go ahead and replace this bulb for you. And I don't know what the warranty on this is going to be, since this is difficult to get to. Usually replacing bulbs is usually something the customer is responsible for, but I don't know how this would be handled. I would check with your RSM just to make sure that this would be covered under the warranty if there was a problem with the bulb or something. So let me show you how difficult it is to get this back in without losing the screw. Like I said, I wish this was a magnetic screwdriver, but we'll do the best we can. So let's see if we can line this up. Hopefully I won't lose that screw this time. I think I got lucky. All right, so go ahead and plug these connectors back in. And while I've got it in this condition right here, I'm going to show you something else before I lay it back down. I can give you a lot of wires here because of these wire ties, but it's maneuverable. All right, what I'm going to do is turn this around. All right, same thing as we talked about on the little cover for your lamp assembly. We've got the same situation. You'll have to snap off those tabs, and then if you remove this, and you might be able to get to this if you're careful, slide it out just far enough to get this door off here. You're going to reuse this, you'll just flip it over the other way. But here's that little motor. We'll talk about a little bit later how to check these. These two first wires here, the black and the brown, that's our 24 volts. The pin number 1, which is the black wire, is going to be your 24 volts, and then your ground, which you'll be using for the other wires. And we'll get into those a little bit later. We have about 4 screws here. 1, 2, 3, 4. So we got 2 back here and 2 up here. Then this whole assembly will come out if you have to replace it. Just make sure that when you put it back in there, there's a rack gear that make sure that lines up. That's the tracking for this. So you can pull that up and down. So this shouldn't be too much of a problem if you do have to service it. So I'm going to snap this cover back on, and we'll move on. Now, one of the things that you might want to do is maybe service that rack gear, or if you have to do anything with the door. Let's show you how to do that. Bring this back to this position. I see what I did. I just went over my service manual. That's where all these pages are coming from. Kind of got stuck in there. So let me move this off to the side. This was some literature I was going to show you guys later. So, all right, while I got this in the position, I'm going to just take a second to put these back on so I don't lose these screws. And then we'll move on and how to get to the track assembly and how to get to the door. If it looks like I'm taking too long, I'll just go ahead and put 1 screw in there. But that's good for now. All right, so I'm going to pop this door open. I'm going to have to go the other way on this because of it's hitting in front of this cart. All right, now one of the ways to make it easier to get to this tracking assembly, which is under this tray here, I'm going to tilt it a little bit so you guys can see what I'm talking about. Let me move this. See if I can do this without dropping this. So we'll tilt this a little bit. See that ceramic bottom there? Now in most microwaves, what they did is that's held in place by silicone sealant. It's food grade silicone sealant. That's not the case here. This is a silicone rubber, but it's actually like a gasket on there. Now back in the corners here, there's little bumps. There's one here and one there. And what they are is there's a roller there, and that roller rides across the cavity of the oven right here. So that little indentation right there is for that roller, and that's why that's there. So when you do remove the bottom of this thing, what you got to do is pivot out the front first, and then you can lift it out. So the easiest way I found to do this is, so we don't damage anything, if you go from the bottom. All right, so what I'm going to do from the bottom is there's a cutout here. You can actually see the bottom of that ceramic tray. And I'm going to put my hand there. And what I'm going to do is push up on this. And you can see the front is starting to come up. So let me go a little bit more. Now I can just actually slide this whole thing out. Okay. Now the next thing you need to do is for this track, for the rail here, you got one on the left and one on the right that this rides onto. We need to disconnect it from the actual door. So with a putty knife or a small screw, there's a little panel, very tiny. Just go ahead and pop those off. I'll just show you what it looks like. So these are these little panels you're snapping off. And in there, there's 2 screws. So you're going to go ahead and remove those 2 screws. Okay. Now to get this off the track, you got to do one more thing. If you guys are familiar with ranges, they have the storage drawer down the bottom. You pull them all the way out, and they have like a little plastic tab. There's one on both sides, and it's kind of like a little arrow. What you're doing on this one is that little plastic tab. See if I can tilt this a little bit, and I can show you where that's at. It's right about here. Okay, so you're going to move it in this direction. That'll release it from this tracking. So after these screws are off, you can go ahead and you can slide this whole thing out. Now you can go on to take this apart even farther. There's a filter choke here. You can once again use a putty knife or something to take that off. The door can be separated from the filter choke in the door glass. There's about 10 screws there. Remove those and you can separate the door. Now, the other thing is this track down on the bottom. After this is out, there's a screw in the front. Remove the screw in the front and it's slotted in. You can lift it up. And this comes as an assembly. You'll get the rack gear track. And then you also, there's what we call an oil damper in the back. And the oil damper makes sure that when it's closing, it doesn't slam into it. So it kind of acts as kind of a damper or buffer at that point. So this is how you can take that apart. Not very difficult. It looks like it's really simple to come apart. So let me pop this back in just in case we need to do anything. Now, once again, I have to go on a pivot because I got these little bumps here because of the 2 rollers in there, and just snap it straight down. Fits pretty good. Kind of keeps the moisture from getting through there. And I'll pop this cover back on. We'll move on. All right. Now you can also, when you take the door apart, you got 2 latch hooks. Those can be replaced. I'll have to check. My fault, I should have checked earlier whether or not this is available as a whole assembly. Maybe if you guys have worked on Sharp, maybe you can answer that question. So, all right, let's move on now. Now, anything else that we're doing is if we're working with the high voltage section, you're going to have to remove it from the counter, okay? Unfortunately, there's no way you can get around that because everything is in the back here. Couple things that you'll have to remove the whole wrapper for is this. Um, you have that cavity fuse, which is located about right over here. The other thing is your stirrer motor. You've got that up here. And right over here is where your noise filter is. That's where your power cord is, and that goes right into here. Um, I think you might be able to, there's two screws holding this cord on. I think you might be able to take that off, and I don't think you can get the noise filter out, but you might be able to get to that 20 amp fuse in case you got a dead microwave. Might be able to get to that, but at that point it's kind of mute. So I'm going to put that control panel on, just snap it on so we get it out of the way, and then we'll go into the back and show you where the high voltage section is. So give me a second here. All right, I'm going to snap this on real quick. I'm just going to put a couple screws in there just to keep it from bouncing all over the place. See how easy it falls down? So just remember to hang on to that when you put that in place. All right, let's get a couple screws here just to hold that in. I think one of the problems is I think I put the wrong screws in this morning. So I'm going to close this and I'm going to flip it around. Ladies and gentlemen, if you do have to remove the wrapper in the back panel, there are a lot of screws there. So you guys all have cordless drills, so I'll probably make the process a little bit simpler for you. But I'm just using a true cordless screwdriver today. We use that here. I know it's not as quick, but we take these apart so many times that the screws get stripped out. So we find we have better luck if we're just using a cordless screwdriver. And I got the monster version this morning. So let's go ahead and we'll pull these screws out of here, and I'll show you the high voltage section here. Now, you notice I have another little panel right here. I'm going to remove that so you guys can see what's behind there. Remember I said there's two boards in the back. We have they call it a power supply. And I look at it as more or less maybe a relay board. But I'm going to go by what Sharp calls it. So you can see that's down there. And it's kind of hard to see, but in the inside, there's another board back there. And they call that the switching power supply. All they're doing is they're taking line voltage and they're changing it into the 24 DC. So if you get things like maybe the auto door doesn't work and you don't have voltage, go ahead and check. Maybe you got a problem with that switching board there. Okay. All right. So let's go ahead and we'll start pulling some of these screws out. I'm going to take this one off over here to show you how much room you got here. See if you can possibly get to that filter board. Now I can see it right here, but I have a part of the extension of the cabinet coming through there. So I have a better shot of just removing this back panel here. So let me continue to take out the screws here. Now there is a Molex connector here. If you want to get rid of this, you can unplug this and get that out of the way. Now we're using kind of old technology on this one. They're not using an inverter system. This is strictly that plate transformer. So stubborn screw here. Just bear with me. I know it's kind of boring watching me take out screws. All right, last screw here. All right, once again, be really, 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 really super careful. Um, this sheet metal is really, really rough. So gotta pop this side off, and I can lift this up. I think we got enough clearance now. We can, did I miss any? Oh, yeah, I missed screws, some screws down here. So once again, I should be wearing gloves. Like I said, this is really, really sharp. Been lucky so far. Um, and one of the things I learned early when I worked on microwaves is always to discharge the high voltage capacitor. All right, they store a charge. Used to have to warn customers that, I'm going to do something that's going to sound like a firecracker. Don't be scared of it. It's just I'm making it safe for me to service this thing. Sometimes we get lax because they made it safer for us. What they did is they put a bleed off resistor inside this capacitor that's going to bleed it off. But we get complaints and sometimes, and we're just assuming that that resistor is okay. So it always still get in the habit of maybe just going across those terminals to make sure that it's not holding a charge or anything. All right. All right. So here's that. They call it this power supply board. I like to refer to as maybe a relay board. We've got these two relays here. One of these is for the lamp, and the other one is for the um, L1 side to the primary side of the transformer. That's that relay you check if you get a no heat complaint. And in the back there, that switching board is right here. And that's the one that takes the line voltage in and converts it into that 24 volts DC on the other side of that. Magnetron's up in the top over here. This is your cooling fan for the magnetron. And your thermal fuse, you'll have to remove this air guide here to get that off. But you can see where the cavity fuse is located at. The other thing here that you'll have to remove it for is your humidity sensor is up in this corner right here. All right. So there's our high voltage capacitor, and they're using what they call an asymmetric diode. And basically what they did is they took two diodes that are in opposite biases. This is your main diode. That's the one you guys are familiar with. But they took another diode and they reversed the bias on it. Now, that's designed as a protection circuit. From what I understand is that we have a problem either with the primary rectifier going out or a problem with the magnetron that could affect the high voltage transformer. So what this is designed to do is if your primary diode were to open or short, this creates a dead short right there, and you're going to take out that 20 amp fuse on that filter board. Okay. So normally when you see the 20 amp fuse go, you check things like door switches and different components that can take out that fuse. If everything looks okay there, go ahead and check that diode or the magnetron. You might have a problem with it. We use something similar. We actually take a fuse. I wish I had one here. I got some at home. I forgot to grab them. But they're a fuse that's in line with the secondary and the capacitor. If you got a dead microwave, no heating, but everything else is working. I've had technicians call me and they said I replaced everything and it's still not heating. They replaced everything on the high voltage side. But what they didn't do is they didn't check to see if that fuse was open. It's got a fuse holder just opening up, and it's a weird looking fuse. Um, the diode is right here. So there's the two. So you can see this is your main diode, and there's the secondary one. And this goes from one terminal to the opposite terminal. Okay. So, all right. Now on your high voltage transformer, we always say there's no reason for checking voltage except for one. This is the way I was taught years and years and years, in fact, decades and decades ago. I always look for the primary side of the transformer, whether I got line voltage there. And that always told me where to go. So if I put meter leads here with alligator clips, put my meter down at the side, set the control panel for about 10 or 15 seconds, power it up. I'd look for that 120 volts there. And it kind of gave me a starting point. Is my problem here or there? Depending if I have or don't have voltage there, I know where to go. Now, some of you guys probably use amp probes. I have no problem with that. Okay. So that's another way of testing to determine, but you always need a starting point. So really that's the only voltage that I would have you guys check when you're servicing this thing. Now, everything, it's always been really easy for me to remember this because I really haven't seen much change over the years. When you're doing the magnetron, that's usually less than 1 ohm, okay? You also want to check it to the case to make sure it's not grounded. When you're checking your primary, same thing, less than 1 ohm, okay? Your filament, same thing, usually 1 ohm or less. The only one that changes, and I've seen them range from different ohm values, this one's about 82 ohms. This is the one on your secondary side, okay? Now that's the one, if that resistance is out of value, it could take out that filter board fuse. And like I said, if you think you can service this, this is kind of tight. I can maybe get my meter release here to check this fuse here, okay? If you can't, you'll have to completely remove that wrapper there. All right. Now we're running kind of tight right now. I got a couple things to cover. So let me show you what I've got in this service information I put together. And I did this back in March. We got this microwave over the holidays last year. And when I came off field training, started working on this. And so it's got everything like I talked about, your key features and some of the installation stuff. But more importantly, it's going to get into how this thing gets taken apart. Okay, let me go to that section. So those little things that I kind of skipped over this morning, it actually gives you a better detail on how this comes apart. Okay. And here's what I was talking about, that track that's held on by that screw. This is that oil damper in the back, and this comes as an assembly. So what we did with this little catch here is we released that. So the 2 halves of this came apart. And then this is how your cover for your stirrer comes off, how to remove the stirrer, and how to get to the lights and everything. But what we really want to get into is some of the servicing. This is your explanation of your door switches, how to check them, what they should be. And then your turntable, not turntable, but stirrer motor. This is for your blower motor, give you resistances and approximate voltages. And then this is your humidity sensor. This basically explains how it works. Understanding it real quickly, it's basically 2 thermistors. One of them is in a enclosure that has clean, dry air. The other one's exposed to the outside air around it, and there's a mesh screen to protect it. So there's 2 components. There's 2 thermistors and there's 2 resistors. And basically what they're doing is they're looking at the changes of that circuitry as its humidity is introduced, and it compares it with a preset level. And when it reaches that, then it's programmed to continue with the cooking so that it is all automatic. So it explains a little more in detail here if you really want to get into how everything works on there. But this right over here is a section on the gear draw motor. What I did is actually broke all these connections down for you. We have what each one of those pins represents. Told you earlier that the first 2 pins, they were for the voltage for the motor, the red and the green. I had them backwards. Actually, they should have been red, green. I told you black and brown. Black and tan is actually something different. But we broke them down. Pin 1 to 2 is where you're going to check for that 24 volts. Pin 2 is your ground. If you go to pin 3, all we're using is a 0 volt DC signal when it's fully closed, and when it opens, it goes to about 1.5. And then we have every little pin on there so you can check it. Now, obviously, if you've got 24 volts there and it's not doing anything, probably got a problem with this board and motor assembly. So, but like I said, everything's been broken down for you. We even got your, must have missed it. Let me go back a couple pages because we did the, Here we go. This is for your control unit. Okay. So each connection, what it does, what the approximate voltage is for each one of those. I don't know if you guys really get that deep into it, but I figured we just go ahead and do it. This is for your power supply. Got each connection broke down and what the approximate resistance and voltages are for those connections. So it's in full color. And like I said, we'll release that at the end of the training session. Okay. So I don't want to spend any more time unless anybody's got any specific questions. I can go to it if you want. Otherwise, I'll move on and get into LG. So, okay. I'm going to go ahead and move this out of the way. I'll come back and I'll put this together later. All right, so I just took an over the range microwave here and I just put it on some rubber block so I can get it up a little bit, but I'm going to kind of use this as my example. This is also a signature microwave, kind of our high end. Let's plug it in. I want to talk a couple things about, I'm sure you guys are familiar with most of these procedures, like how to check for microwave leakage, the what's used and how to do it and when it's required. We got these meters and these I've been using pretty much my whole career. These are expensive. I think the list price on this one a few years ago was about $1,300. I did some negotiating with this company and we were able to get these under $1,000 because we bought a lot of them, but it's a whole kit. Comes with a little container. Now, when you're doing this check, it's required that you have a load in there. I would say never operate the microwave without a load. Okay. Always have something in there. Then you've got your meter here. Now, this is just a kind of an analog meter. You got this cone on here, and this cone needs to be on there. This is a spacer cone. Kind of looks like they did this to protect the microwave from scratching, but that's not the reasoning behind it. It's a spacer because this, where we pick up that leakage, has to be a certain distance when we're checking it. So this acts as that spacer. So real simple. It's got a battery check. You can turn that on. You can also use that to zero your meter. Let's see if I can get that a little closer for you guys to see that. I think we're pretty close there. All right, so I got it close to zero as possible. All right, now one thing when you're using this, it's got to be on all the time. You have to hold this up. All right, so when you release it, it just turns it off. I kind of like that. That way I can kind of save my batteries. Now, what's acceptable and what's not? There's different things that you look at. This is what we use as our baseline. That's LG. And most of the manufacturers I've ever worked for kind of use the same thing, 1 milliwatt per centimeter squared. Okay. Now the federal standard is at 5. Okay. So there's quite a variance between that. But I worked on Amana microwaves, Maytag, Whirlpool, and they're all kind of in this range right here. Now Sharp, on the other hand, their maximum is 4. So they're a little bit less than the federal standard, but they're a little bit higher than other manufacturers. So I think once it's sold under the LG name, I think I would still stick with the 1. And really, I've worked on microwaves for decades, and I really never seen them really get above that 1 milliwatt. I've seen doors that were barely hanging on there and stuff. So if you do get into this range where it's at 5 or above, we're supposed to disable that microwave immediately, figure out what's going wrong with it, get it repaired, and we're supposed to notify one of these government agencies. I think it's the Department of Health and Human Standards or something like that. I might be wrong, but we're supposed to notify them. And like I said, I've never seen one hit that. I don't know if you guys ever did or not. All right. So basically when you're doing this, like I said, a load, I'm going to throw it in there. It's not a race. So with that meter turned on, we're slowly going to move that across as the microwave is running. Just make sure you put enough time in here to go ahead and make sure it doesn't shut off while you're doing this. So a couple things you want to do is like around these edges over here where there's openings, check the control panel, check the bottom. You can do the glass any way you want. You can go back and forth if you want, or a lot of technicians say they simply just make an X across here. They go, and I'm moving this way too fast. It should be slower, and kind of do it that way. So um, now remember, oh, your question? I'm sure there probably has, and that's something that I was going to bring up to you guys. You are required to check these under certain situations, okay? So one of the things is, I don't care what you do to this door, if you replace the handle, if you're replacing a trim piece, if you're replacing a choke on there, it has to be checked. Doing the door switches, okay? I don't care if you're adjusting these or replacing it, it has to be checked. The other thing is if you're doing anything with the magnetron, if you're replacing the magnetron, you have to go ahead and check it without the wrapper off. Now, as far as lawsuits, I'm sure there was in the early stages when I start working on these microwaves. They were really simple. It was $600 and you got this little microwave oven about this big, had a 15-minute timer, an indicator light, and that was really about it. Had one power level on there. Okay, so it was great for making hot dogs. And we were so happy when we got it. But a lot of people, when I start servicing these things, and the company I worked for, this was going to be the transition. We did other things. We had technicians that worked on TVs, and I'm talking these guys used to do tubes on the TVs. That was so long ago. But this was going to be the appliance technicians transitioning over to electronics. They gave us the microwaves. So they taught us how to work on them. So when we used to run service calls, one of the things is most customers would like throw the food in there and close it and walk away. And because they thought they were going to get radiated, it was going to grow a third eye or a third ear or something. So the other thing that we always used to get is, can you check it for microwaves leakage? And fire departments used to have these meters there. You know, the customers can call them and say, "Can you check my microwave? I think it's spewing out radiation, and we're going to get killed from this." And so they would actually come out and they would check it. I don't think they do that anymore. It's our responsibility to make sure that it's safe for them. But we hear less and less of that being an issue. Okay, so remember to mark your results down on your work order so you got proof. You know, maybe a customer says, you know, I got skin cancer because I was standing in front of that microwave and the guy serviced it and he never checked it. But if you put down on there that you checked it, and I would use this formula. So if you got 0 MWC M squared, put a 0 there, say no leakage found. Put whatever you found down there. If you got 1 MWCW, put it down there. Let the customer know this is on their work order, and they can reference it if there's any issues or not. All right. So any questions on how to check this? Oh, because of the cost of these, and I don't know how good this is, but this is what we give our factory technicians, this meter. It's a little bit cheaper, probably considerably cheaper. So it's kind of a digital meter. I got to play with it a little bit. We've got this a few weeks ago and want to compare the two, see how accurate they are. But remember, guys, on this one, they do have to be certified every year. You're supposed to send them down to get recertified. We've been a little lax, to be honest with you, but we only use it in this building here. But for you guys that are dealing with this type of meter at a daily basis, it probably would be a good idea to send it out to make sure it's calibrated correctly and working fine. So, all right, let me throw this back in there. Now, the other thing you run into is sometimes you get customers actually say it isn't cooking the way it used to. Or maybe they got a brand new microwave and they say, "Oh, microwave used to heat up that cup of coffee a little bit quicker. This one's a little bit slower. So I think there's a problem with it." Sometimes there could be. Okay, we can have a problem with, they call it a layer short on your high voltage transformer. Sometimes it's obvious, kind of smells like something's burning. You can actually notice it if you look at the windings on the transformer. You'll see a burn spot that can give you low wattage. You can have other things. Maybe your stirrer or your turntable isn't working. That can affect the way it's working. Very dirty microwaves can do it too. You got a customer that never cleaned inside there. Okay. The other thing that I don't like seeing customers do is some of these come with a two-stage rack. Customers like to store them there, so they just leave it there all the time. And what I've seen happening with those things is um, splatter from food, get in between where the holder is and the wire rack. And eventually it turns into carbon, and it's a very good conductor of microwaves. Okay, starts to sparkle. And the other thing is, sure you guys know how to handle this, is can you put metal in here? Well, guys, when I first started working on microwaves, the magnetrons were different. They were very, very, very expensive, and they were huge. They were about this big. They had a glass tube on the top, okay, sort of like a vacuum tube. And the problem was when you were using metal on that, that metal could bounce the microwaves back to that magnetron, and it could damage the magnetron. Now you can see they're shielded now. There's the antenna, and they have a shield around there, so if microwaves come back, it's pretty well protected. But one of the things they didn't like customers to do with microwaves is cook popcorn. Now, we didn't have microwave popcorn back then, but customers would read these little articles on how you can make popcorn in your microwave. Now, us as manufacturers used to say, no, you can't do that. We didn't like the idea that there was very little moisture inside those kernels, and there was nothing to absorb those microwaves, and they could damage that magnetron. Now you can see it's pretty much standard. It comes on all microwaves, okay? But one of the ways they used to say to make it was, and they had to stop saying this because they had all kinds of problems. They would say, get a paper bag, put your popcorn kernels inside there. And if you want butter popcorn, just go ahead and throw a couple dabs of butter in there. So you can see where I'm going with this. The butter would melt, the paper bag would absorb that. If you left it in too long, the bag would start on fire. So we would try to discourage them as much as possible. But I think the industry just kind of embraces it now. They all got popcorn settings. So I got a little off track, but the thing I was trying to talk about is when you're checking for wattage. Sharp is a little bit different. They say use 16 ounces of water, set it for 60 seconds. And I think the temperature difference from the water going in to coming out should be 28 to 56 degrees Fahrenheit, and they consider that acceptable. This microwave right here is 950 watts. Now, the easiest way to figure out what the output is it's right on your serial data tag. So if you look at it, you'll see output of wattage, and this one says 950. So all microwaves have them on there. So don't always assume that just because this says it's 1,000 microwaves or 1,100 wattage or 950, that's what you're going to get out of there. There's a lot of factors involved, and we're usually in most cases under that. But there is a range. Let me give you the range we're looking at. We're looking for 85 to 115%. So if you got a 1,000-watt microwave, you can get down to 850 or as high as 1150. But one of the things you want to verify first, which could really affect the way the microwave is cooking, is this, the voltage coming into that. Now, usually in this case, you got an over-the-range microwave. Usually they've got the wiring right above in a cabinet there. Open that up. It's usually a spare receptacle up there. You can put your meter there, put a load in there, set it for 30 seconds or so, and check the voltage while it's running. If you're lower than 108, I ain't touching that thing. They got to get that fixed, get an electrician over there, because that's more than likely what's causing my problem with low cooking performance. Now, our way of testing this is a little more complex, all right, but it's pretty accurate. So what we're going to do is we actually have a formula. See this formula here? Looks like you got to be a mathematician to figure out what's going on. We call it specific heat formula. But if you break it down, P is just the microwave power output in watts. The MW here is the mass of the water in grams, and so forth. Okay, let's break it down so it's a little more simpler. You are required a couple things. Of course, you're going to have a voltometer to check for that voltage. And I bought this at a scientific store. They were relatively cheap. I think they're about $4 a piece. They recommend using plastic. Plastic ones do not absorb microwave energy, so you'll get a more accurate reading. So these, we are a Korean company, so these are 1,000 millimeter beakers. So I need 2 of them simply because I want to catch as much of those microwaves as possible. So when you put them in the oven, have them as close together. So take that line and fill it up to the 1,000 millimeter mark, okay? Try to have the initial water under 25 degrees Celsius. So what we're going to do is, and like I said, I'm going to simplify this formula for you really, really simple, is you're going to take this thermometer, you're going to stir it, and you'll get an actual reading out of the first beaker. So let's see what we got for the first one. This one looks like about 22 degrees Celsius. Let me do this one. They should be the same. They were sitting here all night. And this one is 22.2, okay? So I can use that as my starting temperature. So it's 22 degrees Celsius. Now, the reason for stirring and checking it is maybe you just got this out of the customer's tap. This one might have been 20 degrees Celsius. This one might have been 18 degrees Celsius. All right. So what you have to do is you got to get an average. So 20 and 18, add them together, divide them by 2. My average starting temperature on both of these is going to be 19. All right. So let's use this right now. I said 22. Let's mark this down. So that's my start. Now, I'm going to go ahead and put these in here. This is a high-end microwave, so it makes it a little more difficult to actually control the control panel. So it's kind of a convoluted process. We suggest that you use 2 minutes and have it at power level 10. You want the high power level. But I would go one more because part of this formula is excluding the heat up time on the magnetron, which is about 2 seconds. So if you want a totally accurate one, and I don't think it's going to change it that much, but you should be using 2 minutes and 2 seconds. That's the problem with this one. I won't be able to do 2 minutes and 2 seconds. The closest I can get is 2 minutes. So I'll show you how convoluted this is. It probably would get easier if I used it every day. I use manual cook and see it's changing. What do you want to do? You want to do microwave or do you want to do, so there's combo, there's convection. I want to do microwave. I just push it in. Got power level 100. I'm going to push that in. And then what I'll do is I'll turn this to get my time. So I'm going to get as close to 2 minutes as I can. See, it's in 10 seconds increments. So I'm not going to get 2 minutes and 2 seconds. So we'll go ahead and we'll start this. Let it cook for 2 minutes and we'll see what our temperature rise is. Get my calculator ready because I'm going to have to do some ciphering here. Now, I suppose if you can't find Celsius, should be available. I found it, but I guess you can convert it to Fahrenheit and use a regular ounces. Grams is going to be, and milliliters are going to be a little more accurate because they're a smaller scale. I'll get a better indication, but I'm sure we can convert that over if you needed to. So got about just about another minute. And then we're going to show you what we did here. So, all right, we should be about right there. So you're immediately supposed to take these out. Don't let them sit around. And we're going to stir them. So, and then we're going to check the temperature we got here. Let's see what we're doing here. Now, I didn't do the voltage check. That's one of the things I should have checked first. All right, this one is approximately 30, looks like 32. So it looks like I got a 10 degree. Let's check this one. See if this one's close. This one's 32 degrees too. All right, so let me grab my calculator here. So we started out at 22. We ended up at 32. So we got a 10 degree temperature rise. Multiply that at 70. I don't think I need a calculator for that. I got about 700 watts. Okay. Now this is a 1,000 watt one. So basically, got to calculate that to see if we're close or not. But the way you're going to use this is the lowest you can go to is 108. The maximum is 132. Let's say my started voltage was at 114. That'll change this because you can go from 115 as your highest point to 85 at the low point. As long as your overall wattage came out in that range over there, this is considered normal. Now, if I'm under that, then I would have to see why it's under. So I would first check the condition of that cavity, make sure that it's, you know, not really super gross inside there with a lot of things going on. Then when I get into checking things like the layer short, checking to make sure the stir or the turntable is functional. The other thing you want to check is it could all boil down to you have a magnetron that is weak. All right. And you can just replace the magnetron. I've always done this, and I can probably explain to you why I did it. I always replace the magnetron and the high voltage capacitor if I have ever had an issue with low wattage. Then, of course, do the microwave leakage tech, and then go ahead and check this. I think if you do your math, you're going to find that that's a little bit low. Like I said, I should have done a voltage check. I think I got a voltage drop using those cheap extension cords and these little outlets on the desk here. So that's something I should have ruled out right from the very beginning, voltage. All right. All right, we got a couple of minutes. I just want to talk about some of the component testing. I'm sure you guys do this all the time, and I hope I'm not boring you. But I do actually have a magnetron that is bad. I dug it out of the dumpsters. Came back from one of our technicians, and I was looking for a magnetron and struck gold because this is actually a bad one. So typically what I said is you guys are going to get about less than 1 ohm when you check that. Got this set for ohms. Let's see if we can get this meter in there. All right, so what I'm going to do is I'm just going to go across the 2 terminals. So I should, on a good one, get less than 1 ohm. Should be wearing my glasses. I'm seeing 3 terminals there. All right, I can't see. What are you guys reading there? Kind of bouncing a little bit, about 3 ohms. Yeah. Yeah, so that's way too high. And also if you go to the case, now if you don't have an auto skating meter, make sure you have it set for at least R1000. You shouldn't get any reading there. So you can see it's actually grounded to the case here. Also what's missing is there's a choke in here. It's just a wire mesh that fits on here. It's kind of a circle that absorbs those microwaves. So make sure when you're replacing this that the new one has one on there and you didn't leave the old one on there. Now, your plate transformer, and we'll probably, if you guys are interested, we can go back and do another class on inverter technology. We just have a few of them that uses the inverter. A lot of manufacturers like them because shipping weight is down. Look how heavy this thing is. Those little inverter sections are pretty lightweight. Get mixed reaction on it. Some guys say they're garbage. Some guys say they work great. Yeah, it's it looks like a piece of wire that's wire meshing, and it fits perfectly inside here. Okay, so it's made of metal, but it's kind of like a mesh. So I don't have one to show you because I'm missing this one. So it filters out those RF, not RFs, but microwave leaks. All right, so on this one, your primary, once again, less than 1 ohm, your filament less than 1 ohm, but this is the only one that changes. This is your secondary one. So always check the service literature to make sure that you're at the right range. So this is one of the leads. The other one, you can pick it up a couple places. This is usually going to be secured down to the very bottom of the microwave. So you can use that screw there, but there's a lug right here. So this is the other side of that winding. You might have to scrape this off a little bit. Sometimes varnish gets on here. So this one I think is somewhere between 82 and 85 ohms, if I'm not mistaken. So what do we got there? 83. Okay, so we're right in the range. This is one of the things that if that resistance is really out of value, can take out that 20 amp fuse on your board. Okay. I don't have a capacitor, but I do have a diode here. Now, one of the things is this is a stack diode. There's several of them inside here. And it takes about 6 volts to trigger this. So if your meter doesn't have a 9-volt battery in here, this is going to appear that it is defective. But there's a way around it. You can use a 9-volt battery. So instead of using resistance, what you would do is you would actually go to DC voltage. So we're looking for about a 6-volt drop across this diode. So it's kind of difficult to do this without 3 hands, but basically you're going to attach one side to one terminal of the battery. Let's see if we can get this set up so I can show you guys. So I'm going to slide this one in here. I think I got a good fit. Put one of them on the battery. And then the other lead, I'm going to touch the other side of the battery here. So I don't know what it's reading. It should either be 0 or close to 6.
-7.
Okay, so I got reverse polarity on there. So just switch these now. All I have to do is reverse the battery. And I should get 0 on this side. 5. Okay, so on that first one, were you getting like 0.0? Because that should have been, there shouldn't have been any deflection in that first one, or no voltage. I'm going to switch them around again. Is there a decimal point in there? Yeah. So if you get the same reading in both directions, it can indicate you have a shorted diode or you have an open diode. Okay. Remember, this should only have voltage in one direction. So that's your alternative way of doing it. So the last thing I'll talk about is these door switches. These can be adjustable. You can order them individually, or you can order, in this case, we call it a switch bank. So it's got multiple switches inside there. Okay. They have to be synchronized. You've got your primary switch, your secondary switch, and your monitor switch. The only one different is your monitor switch. That one's going to be normally open when the door is closed, and it closes when the door is open. Okay, so they have to be synchronized. These will close your secondary and your primary when the door is closed. They're normally open. So they have to be synchronized. So when you're slowly opening that door, your primary switch should open first, followed by your secondary switch, and then your monitor should close. When we're going in the opposite way, your monitor switch opens, then your primary closes, followed by your secondary. Now, one of the things I learned years and years ago was used to have to work on microwaves in the shop. I used to come in on Wednesday and do these. People used to bring them to us all the time. Microwaves back then were very, very expensive, very, very heavy, and we didn't offer in-home service. Everything was carry-in, so they would bring it in, and they would bring it in because the microwave is dead. So one of the things you do, you take it apart and you see that 20 amp fuse is blown. So you check things, First thing you do is check these things, make sure they're okay. Go ahead and check things on the high voltage side, make sure those are okay. And so basically, didn't find anything wrong with it. So I put a fuse in there, open and close the door a few times. It worked just fine. So in the early days, I used to just say, looks like it's okay, send it out. But you know what happened? And I'm sure you know where I'm going with this. Somewhere down the road, they would call back and say, dead again. So they bring it in again. And what I learned later is sometimes, these switches, depending on what they're cooking in there, you can sometimes look at them and you'll see like oil actually there from all the cooking grease and stuff that's accumulated in there. And what'll happen is these switches might stick on you. So you can try it 100 times, opening and closing that door. It works just fine. But as Faith has it, that customer, the third time they went ahead and used it after they got it back home, one of these switches stuck. And what happened is I had a dead short, took out that fuse. So the company policy at the time, and LG is kind of the same. If you can't find a reason for the fuse to blow, save yourself a lot of time and aggravation. Just replace these switches. Okay, these come as an assembly. Most of the time, there's as three. Now, I'll tell you, our secondary switch is really just a sensing circuit. It isn't in that live circuit. All it's doing is it's looking for that switch being open and closed, and it reports right to the main board. Okay, so the really ones that are going to probably trip that 20 amp fuse is going to be that primary one or that monitor one. And like I said, you don't have time to guess which one. They're inexpensive. You can just replace all three of them. Now, if you have a situation where the customer says, I got the door open and the microwave is running, they panic right away, slam the door. Microwave isn't running. It would have blown the fuse. What happens is the light and the turntable and the stirrer are coming on. And usually what we find is one of these switches is bad. It's usually the secondary switch. Okay. It's pretty common. So go ahead and replace that, and that'll solve that issue for you. So I want to thank you. And really, in the bottom of my heart, I want to thank you for what you guys do. I was a technician for years and years and years, and I'm not out there like you guys are now. Never had to deal with something as bad as you guys are dealing with. So I want to thank you guys.